Hi everyone, I'm here with your 731 lesson, Why Does It Work? Inverse Operations. Variables are useful tools for representing unknown numbers. In some situations, a variable represents a specific number, such as the hop of a frog. In other situations, a variable represents a collection of possible values, like the side lengths of Bonnie's picture frames. In previous chapters, you have also used variables to describe patterns in scientific rules and to write lengths in perimeter expressions. In this section, you will continue to work with variables and explore new ways to use them to represent unknown quantities in word problems. The mathematical magic trick is 779. We're actually going to skip that and move on to 780. "780 says, now you get to explore why the magic trick from problem 779 works. Schuyler decided to represent the steps with algebra tiles. Since he could start the trick with any number, he let an X tile represent pick a number step. With your team, analyze how this work with the analyze his work with the tiles, then answer the questions below. So part A says, for the second step, add 5. What did Shaker do with his tiles? Let's take a look. So second step right here is add 5. What did he do with the tiles? Well, he added 5 unit tiles. Okay. B says, what did Shaker do with his tiles to double it? Explain why that works. So we're looking at double it. That's step 3. What did he do with his tiles? Go ahead and try and answer that. Okay. So if you're back with me, you could say something along the lines as, he doubled the tiles by duplicating the row again. So he had 2 rows of x plus 5. Okay, so let's take a look at that a little bit closer. He had in step 2 x plus 5, but in step 3 he doubled it. So now he needed to have 2 rows of x plus 5. C. How can you tell from Shakar's table that his trick will always end up with 3? Explain why the original number does not matter. So go ahead and try and answer part C. And remember, subtract the original number. Use your final step here to help you. If you're back with me, you've tried to answer that. You hopefully said something along the lines of that there are no X tiles left. So therefore, the original value of X does not matter. Okay. So let's look at 781. 781 says the table below has the steps for a new magic trick. Use the resource page to complete parts A through D that follow. So on our resource page, we're on 781, which is at the bottom. And we're going to kind of do this together. So pardon me because I'm going to go back and forth. Part A says, pick a number and place it in the top row of trial 1 column. Then follow each of the steps for that number. What is the end result? So we're going to say 5. Okay. Add 2, 7. Multiply by 3, 21. Subtract 3, 18. Divide by 3 is 6. Subtract the original number, which would give us 1. So when we fill this out, what was the end result? The end result was 1. Okay, let's look at B. B says, now repeat the process for 2 new numbers in trial 2 and trial 3 columns. Remember to consider trying fractions, decimals, and 0. What do you notice about the end result? So what I would like you to do, I'm going to give you the 2 numbers I want you to try. I want you to try half and 0. So go ahead and fill that out. If you're back with me, you filled out your chart and answered the question, what do you notice about the end result? So the pattern seems to always result in 1. C says, use algebra tiles to see why your observation from part B works. Let an X tile represent the numbers chosen in step 1, just as Shakar did in problem 780. Then follow the instructions with the tiles. Be sure to draw diagrams on your resource page to show how you built each step. So we're going to walk through this together. So we're going back to our algebra tile, our resource page. Pick a number. Well, remember, we don't know what our number is, so we're just going to represent it with X. And it's positive, so it should be shaded in. Step 2, we need to add 2. So we have our X tile again, plus 2 unit tiles. Now in step 3, we need to multiply by 3. So this 1 row of X plus 2 now becomes 3 rows of X plus 2. Okay. Then we need to subtract 3. So when we subtract 3, what do you think that we are subtracting? We could just subtract 1 unit tile from each. So now this becomes so when you divide by 3, we have X and a unit tile left. And we subtract the original number, which is X, which just leaves us with 1 unit tile. Okay. So we've done part C. Part D says, explain how the algebra tiles help show that your conclusion in part B will always be true no matter what number you originally select. So same thing as what we talked about on the previous problem. The X tile is no longer there. So the original number doesn't really matter. Okay. Let's look at 782. (782) says, now reverse your thinking to figure out a new magic trick. Locate the table below on the 731 resource page and complete parts A through C that follow. So we're on our next resource page, and we're going to follow our directions. It says, use words to fill the steps of the trick like those in the previous tables. Okay, so I want you to go ahead and fill in the steps. So if you're back with me, you should have filled in the steps. So we started with pick a number. Our next step is that we added 4. Then we doubled it because now we have 2 rows of x plus 4. Then we subtracted 2. Then we divided by 2. And we subtracted 3. B says, use your own numbers in the trials again, considering fractions, decimals, and 0. What do you notice about the result? So I'm going to give you some numbers. I want to do 0, 3, and 3/4. So go ahead and fill out your trials for that. If you're back with me, you've answered the question B and filled out your own trials. So the thing that you should have noticed in part B was that the end result is your original number. Part C says, why does this result occur? Use the algebra tiles to help explain this result. So go ahead and pause the video and try and answer part C. Okay, if you're back with me, you've tried to answer part C. Part C is asking why this happens. Well, this happens because after all the steps, you are only left with the x tile. Okay. Finally, one more question. 783 is a question that I want you to try on your own. Inverse operations. So we talk about inverse operations. Remember, inverse means opposite. So I want you to try 783 on your own, and that is going to be a question that we talk about in class. As always, if you have any questions, please email me. Make sure when you're done that you upload a picture of the assignment to Google Classroom.